Hello and welcome to this tutorial. Thank you for watching this video and following us. Please subscribe our YouTube channel under Udera Academy for more tutorials and exercise. In this tutorial, I'm going to introduce the topic couple. In previous lectures, vector, force, and moment were covered, which are the basic concepts of statics. Couple can be considered as an extension of moment. Couple takes place when two force vectors act on a body where three conditions must be met. So, two force vectors with three conditions. The first condition states these two vectors must be of the same magnitude. So the first one is the same magnitude. The second condition states these two force vectors must be parallel but on the opposite direction. So the second one is opposite directions. And the third one states they must be non-collinear. So the third one is non-collinear. Now I'm going to implement these three conditions on this arbitrary shape. So if it is a rigid body, this is a pair of two force vectors. This is F and this is minus F because based on the second condition, they must be on the opposite directions. So if the first one is F, the other one is the negative of the first one, which is minus F. Then they are on the opposite directions and non-collinear. They are not collinear. So I'm going to find the moment of these two force vectors about point O. So if the distance separating these two vectors is D and this distance is A, the moment of these two force vectors about point O will be F times A plus D minus F times A. After simplification, the moment will be F times D. So as you see, the moment of these two force vectors about any point like O on this body is the magnitude of these two forces times the distance separating them. So note that when couple condition is met, the moment is independent of any point on the body. Therefore, only the distance separating two vectors affect the result. In other words, couple contains any existing point on the body. So d is the distance between two force vectors and f is the magnitude. When the conditions are met, the moment, the couple, is the result of the multiplication between the force vector magnitude and the distance separating the pair of force vectors. Also, besides the algebraic expression mentioned, couple can be expressed using the vector cross product. So let's consider the same pair of vectors f and minus f, but this time instead of algebraic expression I'm going to use the position vector. So another body, this is minus f, this is f, and again a point like O. I described the position vector in the tutorial of moment, so you can go and watch that video to have better understanding of the concept. So each of these force vectors has a position vector from any point on the body such as O. So positioning vector stretches from O to any arbitrary point on the line of action. So I call this one R1, this is R2, and also the positioning vector between these two force vectors is R. So MO will be F. So first the positioning vector, because this expression is vector expression, so the order is important. R2 cross product F minus R1 cross product F. It can be written as R2 minus R1 cross product F. Recalling from vector subtraction tutorial, the vector expression of couple can be written as R is equal to R2 minus vector position vector R1. Now I can substitute R with the bracket, which will be MO is equal to R cross product F. And this one is the vector expression of couple. But in most cases, as I mentioned in the tutorial of moment, we will use the algebraic expression. But anyway, it's better to know the vector expression as well. So we will solve some problems regarding couple in the next videos.